This is Quick Clip 1.08, Kinetic Energy and Potential Energy Math. And in this lesson, we're going to review all of the necessary information to complete the assignment 1.08. So the first few questions deal with certain concepts of the ball or of an object in position, first in position A, where it's sitting on top of a building, ready to fall. And so it's not moving yet, it's just sitting there. So that means at this point it has 100% potential energy and 0% kinetic energy because it is not moving. Then when it does fall, we freeze frame it and consider its position at point B when it's halfway down from the top. And here it's going to have 50% potential energy and 50% kinetic energy because it has fallen halfway and it has lost half of its potential energy. Next, the next position is position C, where it is just about to strike the floor. And so it's just the instant before it hits the ground. So it will have 0 potential energy because it can't fall anymore. It's just about to strike the ground, and it's also going at its fastest velocity, so it will have 100% kinetic energy. And it's important to understand the difference between acceleration and velocity when doing these potential energy and kinetic energy problems. So first, we'll say that we're driving in a car and accelerating it, and it's going faster and faster, and the acceleration is going to be at 10 kilometers per second every second. So we're going to go faster by that amount every second. So we're going faster and faster at that rate. And then let's say we freeze and we take a picture of the speedometer at a particular point in time. So we took a picture of the speedometer and it was at a place where it is going 190 kilometers per hour. And this is the velocity. It's the velocity of the car at a particular moment. So when we took the picture, when we took that snapshot, this is what we saw. It's frozen at 190 kilometers per hour. So again, the acceleration is the rate that velocity increases, and we use the acceleration in potential energy. And in this case, we're using the acceleration of gravity because we're talking about a falling object. Velocity, on the other hand, is the speed of the object at a specific moment. So at this moment in time, it was going 190 kilometers per hour, and we use velocity in the equation for kinetic energy. So you have to keep that in mind, where acceleration is being used for potential energy and velocity, however, is used in kinetic energy. All right, so let's go through some of the problems here. We have a 2-kilogram bowling ball sitting on top of a building, same situation that we just covered, and we're going to determine its potential energy and the kinetic energy. So here we have 2 kilograms. Gravity is at a rate of 9.8 meters per second, and it's 40 meters off of the ground. So when we plug it into the formula, PE equals M times G times H, we have PE equals 2 kilograms times the acceleration of gravity, which is 9.8 meters per second squared, times the height. So 2 times 9.8 times 40. When we multiply that through, we get potential energy equals 784. Now, calculating kinetic energy, kinetic energy's formula is 0.5 times m for mass and velocity squared. So here we have Ke equals 0.5 times the mass, which is still 2 kilograms, but the ball is not moving yet. It's just sitting there, so its velocity is 0. So we're going to multiply that by 0 squared. And whenever you multiply by a 0, your answer will be 0. So our kinetic energy is 0 joules. The next situation is when the ball is falling, and we kind of freeze frame it and we calculate its potential and kinetic energy when it is halfway down. All right, so at this moment, it's no longer 40 meters above the ground, it's only 20 meters above the ground. So we're going to use that height for its potential energy. So potential energy is going to be the mass, which is again 2 kilograms, times the acceleration, which is 9.8, but now it's times 20 meters because now it's only 20 meters above the ground. And so we have a potential energy of 392 joules. Next, we'll calculate kinetic energy. And again, kinetic energy uses velocity. It does not use acceleration. So in just like in the explanation I gave a few seconds ago, it is the speed at which the ball is going at this very moment. And it says that halfway through, the ball is traveling at 19.8 meters per second. So that's the velocity. Plug that into the formula. We have 0.5 times 2 times 19.8 squared. And that's our velocity, and the formula says we have to square our velocity. So putting that through the math, the calculator gives me kinetic energy equals 392 joules. So here you can see that potential energy and kinetic energy are the same, right? 50% potential, 50% kinetic, and they are equal. Next, we have the final scenario where the ball falls and it's just about to strike the ground. And so its height is going to be 0 because it's just before impact. So PE equals the 2 kilogram ball times the acceleration of gravity, 9.8, times 0 meters because it cannot fall any further. It's just about to strike the ground. And so anything times 0 is going to be 0. Potential energy equals 0 joules. Here, to calculate kinetic energy now, we have 0.5 times the mass times velocity squared. And again, the velocity at this moment is now 28 meters per second, of course, because the ball is falling and getting faster and faster. And so when it strikes the ground, it will be going 28 meters per second. And so putting that into the formula, we get 0.5 times 2 kilograms times 28 squared meters per second. And then when we calculate that out, we end up with 784 newtons, and that equals the potential energy that we started this system with. So to review our answers, we find out that the total energy, potential and kinetic, will always be equal. So when the ball was at the very top, we had 784 joules of potential energy and no joules of kinetic energy, and the total energy was 784. Halfway through, PE was 392 and KE was also 392, so it was a 50-50 split. When we add that together, we get, again, 784 joules. Total energy equals the same. And then lastly, when it's just about to strike the ground, we have a potential energy of 0, and all of the energy now is in kinetic energy, and that was 784, and our total energy again is 784. All right, if that was confusing, please go through it again, but like I said, this gives you all the information you need to complete lesson 1.08. Thanks for watching.